Hello everyone, this is the second part for 3.3, and in this part we want to see uh, some more properties. So first of all, uh, we want to find the x-intercepts of a quadratic function. Okay, so first of all, if you remember your x-intercept, or rather, sorry, the quadratic function looks like this: x squared plus bx plus c. So that's how your quadratic function look like, and from this we want to find the x-intercept, and for that the best way is to calculate the discriminant. Now what's that? We define the discriminant by b squared minus 4ac. Okay, and of course all of this a, b, and c's comes from this, or rather come from this. Okay, so if we have b squared minus 4ac is strictly positive, we'll say that we'll have two distinct x-intercepts. Now what does that mean? That means the graph will go past the x-axis in two different places. Okay, soon you will see examples of those. I'll try to show one example of each. If I can't, you will have plenty of examples on YouTube, on different books, on your books as well, on your book as well. So check those. Okay. If it's zero, if the discriminant is zero, then we'll say x actual, or rather our x-intercept is only one. That means we'll have only one place where this graph will just touch the x-axis. Okay, just touch that. It won't really go past the x-axis, but it will just touch or actually go through it. Okay, but it won't really come back like this one. Only touch, or it could go through, but as we are calculating the quadratic equation, it won't go through. It will just touch the x-axis. Okay, and if we have a strictly negative discriminant, then we'll say we won't have any x-intercept. Okay, it doesn't cross, neither touch the x-axis. Okay, now let's see one example of it. Okay, at least try and do one example and see if we could do more. Okay, so our example is f of x is negative 2x squared plus 4x plus 2. Okay, from this you can calculate whether it's concave up or down. Concave up or down. You can calculate the vertex as we have seen in the previous problem. We can calculate the axis of symmetry. That is, we have seen in the previous problem as well. So I won't go to that. We want to find, first of all, the x-intercept. Okay, then we'll show the y-intercept as well. And y-intercept is pretty easy. You know that whenever you plug in x equals 0 in your original format, you will get actually y-intercept. Let me show that first. So if you plug in x equals 0, you will get your y-intercept, right? Oops, sorry. You'll get your y-intercept. So you can clearly calculate that f of 0 would be 2. So this will be your y-intercept. So for x-intercept, number 5, x-intercept, all we need to do is to calculate the discriminant, this guy. Okay, so on this occasion, our a is negative 2, b is 4, C is 2, right? See, if we calculate the x-intercept, let's see what happened. So first of all, by checking this, you can actually see the number of intercepts. Okay, see the difference. You can see the number of intercepts. You can't really calculate the exact point where it's intersecting. Okay, this will give you an idea how many intercepts will be there, not what is the intercept. It will not give you the intercept itself. It will just give you the idea on how many intercepts you will see. So let us first see that. So our A is -2, B is 4, so B squared is 4 squared minus 4AC. 4A is -2, C is also 2, so it's 16 plus 16. So did I do it wrong? B squared minus 4A and C. What happened? Did I do it wrong somehow? No, it's okay. Yeah. So yeah, so we'll have 32. So as this is strictly greater than 0, our intuition should say we'll have 2 distinct intercepts. Okay. Now, how can we calculate that? We know that if we plug in y equals 0 and solve it for x, we can calculate our x-intercept. So y on this equation is -2x squared plus 4x plus 2. If we set this to 0, -2x squared plus 4x plus 2 equals 0. If we want to solve it for x, oops, sorry. If we solve it for x, we can always use the equation of quadratic, or rather quadratic equation, right? You can use that formula, and that is, if you don't remember, let me write that for you. The quadratic equation, if we have a quadratic equation, the solution is -b plus minus the discriminant, that means the square root of discriminant rather, for a c over 2a. If you plug in the values of a, b, and c on this, you will find the result for x, or in other words, the x-intercept. Okay, let's do that. So x will be, we know that b is 4. B is 4. Here it is. So it will be -4. We know the discriminant is 32, so it will be square root of 32. 2 times a is -2. So if we solve it, let me just simplify it first. It will be -4. If we simplify it further, we'll get a plus minus square root of 2. So that means one of the intercepts will be 1 plus square root of 2. The other intercept will be 1 minus square root of 2. If you plug in 1.414 in place of the square root sign, or rather square root of 2, you'll get approximately a negative, or rather, sorry, for the first one, it will be a positive 2.41. As you can see, 1 plus 1.4, so it will be 2.414, and it will be a negative, approximately a negative 0.414, right? You are subtracting 1.414 from 1, it will be 0.414. So these are the x-intercepts. Okay. Okay. So Now, we want to graph a quadratic equation by using its vertex, axis, and intercepts. Okay, so if we are given a particular function, we can calculate these 5 things from that, whether it's concave up or down, what's the vertex, where is the axis of symmetry, what's the y-intercept, what's the x-intercept. We can calculate all of these from a given function. So now what we want to do, we want to graph a particular function using this informations, rather than taking x randomly and getting the functional value and do that. No, we want to use these informations and we want to graph it. Okay, so first of all, from this graph, uh, let me write the informations for you, and let me write the function for you first. 2x squared plus 4x plus 2. Here a is negative, so it will be concave down. So you will have a bowl facing upwards, right? Something like this. Your intuition should straight away say that we'll have a figure like this. Okay, it's concave down, the vertex. So what's the vertex of this? Can you see that? So if we just calculate your what's that, h and k's, we can actually calculate the vertex from it. So our h was negative b over 2a. So on this occasion, it would be negative 4 over 2 times negative 2, as a is negative 2. So negative negative will get cancelled. 4 over 4, it will be 1. And the functional value at 1 will be, so it would be negative 2 plus 4 plus 2, negative 2 plus 4 plus 2, so it would be 4, right? So our vertex looks like 1 comma 4. We'll soon see whether it's right or not. And the axis of symmetry, as we know, is x equals h. So x equals 1 will be our axis of symmetry. We know we have just calculated the y-intercept. The y-intercept is basically, where is that? Yeah, here we go. Is 0, 2, right? That's our y-intercept. So y-intercept is 0, 2. X-intercept is 2.4 on 4, 0. 4 on 4, comma 0, and the other one is negative 4 on 4, negative 0.4 on 4, 0. Okay, these are the informations you already have. Okay, and using this, we want to graph it. Okay, so first of all, let me use that. Let me use this shorter space and see how we can use this. So first of all, oops, sorry. So first of all, I know the vertex is at 1, 4. So let's see where is our 1, 4. 1, 2, 3, 4. That should be our 1, 4, right? I know that. And as this is a concave down, I know this graph will look like this. So this graph will actually go to the downward side, right? Let me erase this and do it precisely. We also know that we have the y-intercept at 0, 2. That's our 0, 2. So this will definitely go through that point, right? We know the x-intercept is at 2.14, 2.4 on 4. That's slightly less than 2.5. That's 2, that's 3. So slightly less than 2.5 should be somewhere here, very close to that red line, right? And that's 1, that's 2. We know the other intercept is at 0.4 on 4. That's our half, it's slightly less than half, so it should be somewhere here. Okay, so we know the graph will actually go through these 3 points, this green one here, this blue one here, and this red one here. We know the graph will actually go through these 2 points. Okay, and of course we also know we have a point of symmetry at x equals 1. So that means we can actually draw a vertical line which goes to the vertex and x equals 1. We know it's parallel to the y-axis, so that's our axis of symmetry. Axis of symmetry. Okay, and now we can actually draw this. Now we know that this graph on either side will be pretty much the same because this line is the axis of symmetry. So whatever shape we'll have on our left will actually have the same shape on our right as well. So this graph will go through this, this will go through this. So that's our graph. Okay, how far can it go? It can go up to negative infinity, right? You can see that. So that's how our graph looks like. Okay, so that's it from 3.3. Again, you'll have plenty of examples on the book. Uh, you don't need to try any other examples which I haven't really discussed, but of course the examples, or rather the topics, the contents I've showed, you need to practice more of this. Due to the shorter time, I can't really discuss more examples, but again, uh, you'll have plenty of resources on these, and of course you'll have your book as well. Go to that, find problems where you actually need to graph a function by using these informations. You will see plenty of those, and I hope uh, you can practice those. uh, you can um, send me emails if you somehow can't really solve that. Okay. Okay, so just before wrapping it up, I just want to show one more content. I think I need to show this. I would have avoided it, but I think you need to know this as well. So what if instead of using those informations, your questionnaire said you can only use the vertex and one other point. Instead of those informations, you can only use the vertex and this. So first of all, what we want to do is we want to find the vertex from a particular um, problem and see how does it look like. So let's try this example. X squared 6x plus 2. Okay, so first of all, what's the value of a here? The value of a here is 1, which is greater than 0. So definitely our graph will look like this. It's concave up, right? It's concave up, we know that. So at least we know the graph will look like this. If we have multiple choice questions, at least we know by just eyeballing the question that the graph will definitely look like this. Anyway, so what's the vertex? The vertex is minus b over 2a. Here b is 6. 2 times 1, so negative 3, right? So the vertex would be f of 3, negative 3 squared, 6 times negative 3 plus 2. So 9 minus 18 plus 2, negative 7. So our vertex clearly is negative 3, negative 7. All we need is one other point, and then we can actually graph it. So the best way, I think, is to find the y-intercept. Okay, we can plug in x equals 0. That's quite easy. because for the x-intercept you have seen that we need to calculate some, using this formula, we need to calculate something really complicated. It looks complicated. It's not, to be honest, but it does look complicated anyway. So the best way is to find the y-intercept by plugging in x equals 0. If I do that, f of 0 would be 2, right? Because our original function, if you remember, was, so this will be 0, this will be 0, you have 2. So our rather y-intercept will be 0, 2. We know the vertex, we know one other point, we know it's concave up, it will look like this. We can actually graph it. Our vertex is at negative, I think I should use more space on my left instead of this. Yeah. So -3, -7, let's say that's my -7. That's my, let's say, -3. So -3, -7 will be somewhere here. Okay. And I know the y-intercept is at 0, 2. So let's say that's my 2. That's my 0, 2. So this graph will, oops, sorry. This graph will actually look like this. Okay, this is your graph, as simple as that. It's not the precise graph, but you can actually see that it's actually right. You can go precise by checking the points or other information, but that's how your graph will look like. You can actually use these 2 points, vertex and the other point, and graph it. Okay, so that's it from 3.3. The next video I'll discuss 3.4. See you then. Bye-bye.